Good morning, student. Today I am going to explain the factors affecting the resistance. In other words, what are the factors on which resistance depend and how these factors affect the resistance of a wire or conductor. Following are the four main factors on which resistance depends. First factor is length of wire or conductor. L is the length of wire. It is found by experiment that resistance is directly proportional to the length of the wire or conductor. Directly proportional means if length is increased, resistance will also increase. If the length is decreased, this implies that resistance also decreases. This means if we have two wires of same material, one wire is longer than the other, the longer wire has more resistance than the shorter wire. If the thickness of both the wire will be same, in such condition, material also same, the long wire has more resistance than the short wire. That's why we have to prefer a short wire, not a long wire. So this is the first factor, length of the conductor or length of wire. Second factor is area of cross section, that is the thickness of the wire. Thickness of the wire or area of cross section. In our daily life, we see some wire is thicker, some wire is thinner. Material is same by which the wire is laid. So according to this law, resistance of conductor or resistance of wire is inversely proportional to the area of cross section. That is the thickness. This means if the thickness of the wire is increased, in such condition resistance decreases because it is inversely proportional. If thickness of the wire is decreased, this implies that resistance of the conductor increases. In other words, we can say that if we have thick and thin wire, length is same, length remains same, but thickness is differ. It is found that a thick wire has less resistance than a thin wire. That's why we have to prefer in electric circuits thick wire. In this case number 1, we have seen that same material, but one wire is shorter, other is longer. In second case, length of the wire will be same, but one wire is thicker, other wire is thinner. So a thin wire has more resistance than a thick wire. That's why in electric circuit we will prefer thick wire instead of thin wire. Now third factor is nature of material. In our daily life we use sometimes aluminum wire, sometimes copper wire. These two are more popular in our surrounding, in our locality. But if we prefer silver wire, it is better conductor. By experiment it is found that silver is the best conductor. This means it has less resistance. When we compare these two, silver and copper, we find that silver is better conductor because it has less resistance. Copper has better conductor in comparison to aluminium. This means if length is same, thickness is same, and we have three wires. One wire is made up of silver, another wire is made up of copper, and other wire is made up of aluminium, length and thickness both are same, despite of which silver has less resistance. This means conductivity of silver is better than copper and the conductivity of copper is better than aluminium. This is the nature of material. That's why in market, in our locality, silver was costly than copper and copper is costly than aluminium. This is nature of materials. One more factor is temperature. Resistance of pure metal. We use different type of metals in our daily life. Some metals are pure and some metals are mixed, that is alloys. So by increasing the temperature, the resistance of pure wire also increases. If you rise in temperature, rise in resistance of pure metal. But for alloy means a materials having composition, two or more metal may be there. Alloy, there is no any effect of temperature or rise in temperature on the resistance of an alloy, that is the nichrome, tungsten, manganese. These are the example of alloys having two or more metals mixed together in certain proportion to make the alloy. So these are the four factors on which resistance depends: length, area cross section, nature of materials and temperature. And that's all.